Hello, good morning. You should see my desktop and everything should be okay. Does it seem like everything's all right?
Good morning, yes.
Okay, so you can hear me and you can see the desktop. Everything seems right then. Okay, so, all right, we're going to continue talking about arrays today. Now let's see. Oh, no, first let's uh, remember the midterm exam is the second exam is going to be this week, okay, on Thursday. Okay, Thursday's April 1st. Okay, so first, anybody have questions about review problems? There's any review problems that anybody want to ask about? Anything in the review that anybody wanted to ask a question about?
Um, number five, please. Actually,
Number 5? Okay, let's see. Okay, so it's a pretty typical nested for loop problems. Okay, so we have to a row of size 1, a row of size 2, a row of size 3. So we're going to need, okay, let me open up the Java visualizer so we can write the code there. Okay, all right, so to get a shape like that, you need nested for loops. One loop that's going to pick the row. Okay, so I need an outer loop for int I equal 1, I less than or equal to, let's see, now how many rows are there? There's 1, 2, 3, 4, 5, 6, 7, 8 rows. So I'll loop 8 times. Okay, so there's the outer loop. Okay. Okay, then I have to, now this picks a row. Okay, and in each row I go across. So I need another loop to go across. So now I need a loop in here for int, now I'll use a different letter, j equal 0. I'm sorry, j from 1, j. I don't know here. I have to think about. What do I go up to? Okay. J plus plus. Okay. And then there's the inner loop. Okay. Now the inner loop's going to print things. And when you get to the end of a row, you have to go back to the beginning of the next row. So in here, it's going to be system.out.print something, not sure what yet. And at the end of a row, there should be system.out.print line to give us to go back to the beginning of the next line. Okay, so this will go across one row. This loop will go across one row. Okay, and then this one will end the row and make us go back to the beginning of the next line. Okay, so now the question, next thing is, how many times do we go across a row? Okay, in row 1, okay, actually, instead of constantly switching back and forth between the two, I should just copy and paste that into the problem so we can see it in one place. Okay. Okay, so there we can just see the problem in one place. Okay. Okay. In the first row, I have 1 item. In the second row, I have 2 items. In the third row, I have 3 items. And notice it's a pattern. Row 1, 1 item. Row 2, 2 items. Row 3, 3 items. So how many items are in this row? It's I, the row number, that tells us how many items are in that row. Okay, so J will go from 1 to I. I picks the row, and we can see there's 1 item in row 1, 2 items in row 2, 3 items in row 4, 4 items in row 4. Okay, all right. Now, last thing is what to print. Okay. Oh, you can check that we're on the right track here by just printing a star, for example. suppose you just print a star there, okay? And you want to just check, see what it's going to do. Go to the end, and there's the right pattern. But notice I can see I'm missing something. There should be a space between these things. Yeah, there should be a space between these, so I could see that I need a plus space. Yeah, I need I'll need to put a number here, but I'm going to need a space there. So let me just check. Okay, so there's spaces, there's stars spaced out. Okay, now the question is what number to print there. And notice it counts. The number just goes 10, 11, 12, 13, 14, 15, 16, 17. So I'm just going to count from 10 up to 45. And I think the easiest way to do that is the following trick. Print an X, okay? But up here, say int X equal 10. Okay, so X starts out as 10. I'm going to print X, but right after I print X, I have to increment X, so that the next time it prints, it'll be ready to print the next number. So X is 10. By the time I get here, I'm going to print 10. Then I'll change it to 11, loop around, print the next number. But the next number will be, well, then we know that it's going to print one thing on this row, and then two things in the next row. But after it prints 10 on this row, it'll start printing 11 on this row, then 12. So let's check. Okay, just go to the end, and there's the output we wanted. Okay. Yeah, see, there it is. Now notice that you build it up slow. The way to do problems like these is to just use what you've seen. Use examples you've seen before. Like that looks a lot like one of the patterns we did in class. So we did several different examples that are different, like triangular shaped patterns. So you start with something you've seen before. To get a pattern like that, you need nested for loops. Okay. You know that the inner loop is going to go across a row, and it needs to be terminated. The row needs to be terminated by a print line, so that when you get to the end of the row, you go back to the beginning. And then the detail is, okay, what exactly goes in here, for example? Yeah, what exactly do you print in each row? Now, this one didn't need two loops inside here. It would have, if the problem had been like the harder case would have been something like this, where you have spaces at the beginning of a this is a slightly harder one. See, that one puts spaces at the beginning of each row. Okay. Now, how would I like if this is the problem? How can I take what I have? How can I take what I have? Whoops, I messed up down here. Okay. Oops, still not right. There. Okay. Now, okay. Tell me, what can I do to get this output from what I have here? Okay. So let me open another visualizer so I can keep that one and try a different one. Okay. Okay. Now, what about this? Damn, what should I do? What should I do to get this one?
You should just change your system.out statement to put the spaces before printing the variable.
Okay, so tell me something I should write.
Just take your original statement, system.out.print, and then put plus the spaces, and then put plus X.
Oh, but how many spaces should there be? See, yeah, how many? See, the number of spaces keeps changing. So it's, a certain number of spaces on this line, a certain number of spaces on this line. So I need to have, if I put the spaces here in front, I need to know how many. So I can't do a literal like this because I don't know how many there should be. I could have a variable, but I have to figure out what that variable should be.
I was thinking you could make a string variable called spaces, and then at the end of the for loop, you add you remove a space from the.
Okay, so string s equal. Okay, there's an m. Well, so start off with like have it start off that long.
Oh, you could add spaces to the variable inside of the for loop, inside of the first nested for loop.
Yeah.
And you can remove a space from it every time it prints.
So what? So use a variable or use something else?
I think you can keep the variable. God, sorry.
Yeah, there's a bunch of now we did problems like these in class. How do you remember? How did we do something like that in class? We did. Now this is one way to do it. You could do it with a variable. Okay. And actually there were some review problems that were kind of like that. There were some review problems that said use a string variable like this to get a pattern. See? So you could these problems here, like problem 3, and another one was problem set 2, said use these variables to get that pattern. So your idea, that's one way to do it. I'd have to start with a certain string variable and then manipulate it. But that's actually not what we did in class. What was the trick we used in class to get shapes like this? When we did a bunch of examples like this in class, what did we do?
Didn't we use escape sequences or escape characters?
Not to get leading spaces like these. See, here in that row, this actually still prints the right thing for that row. That row, remember, it needed a 10 on it, and now it needs a 10, but after the spaces. Before it needed 11, 12 in the next row, and here it needs 11, 12 in the next row, but after the spaces. So this is still correct. Okay, this stuff is actually still correct. But how did we get leading spaces in the examples we did in class?
I genuinely don't remember, but I think I have a way where or a way to get the leading spaces. I don't know if this is the way we did it in class, but you could have just another for loop.
That's the way we did it.
Okay.
Yeah. The other way we did it was to have another for loop here. So for int int j equals 1, j less than or equal to, I don't know what yet, j plus plus, okay. What would this loop do? This loop would print out a certain number of spaces. Okay, this loop's just going to print a certain number of spaces. Okay, now let's make a little table of how many spaces we need. We need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. We need 21 spaces in row 1. Okay, so in row 1 we need 21 spaces. Okay, and then in the next row we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 spaces. Okay, now the number of spaces goes down by what? Yeah, it's going to go down by 3. I should have gone down by 3. Maybe I miscounted. The number of spaces should have gone down by 3. So let's see if I counted one of those wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, I miscounted the second one. See, 18. So it goes down by 3. Okay, in row 2. And then we know this will go down by 3. So this will need 15 spaces in row 3. Now we have to figure out what to do here. Now notice that J is going to see, one way to think about it is I'm going to go down by 3s. J equals J minus 3. See, that would take me down by 3s because I go 3 less. I have 3 less spaces, then 3 less spaces, then 3 less. And maybe if I could just start with 21. Start with 21. Start with 21. Keep on going while I'm greater than 0. You can see at the end I have 0 spaces. So let's see if this will work. I'm going to print out spaces and I'm going to count them down from 21 spaces, count down by 3 to 18 spaces, count down by 3 to 15 spaces. So this will count us down by 3. And then we'll keep going until we hit okay. Now let's see. Oh, no, that's not quite right. Because this will always start with 21 and count down by 3. Yeah, this is almost right, but it's not quite right. Let's just print this out. This isn't going to be right. Oh, I don't need that one now. We're not using the literal. Instead of using the string, we're going to use the for loop. Okay, see, I just have this constant, I have the same thing in front every time. See, I ended up, that loop just did the same thing every time. It just put these spaces here. Okay, but I needed to put, okay, so I think I have the right idea. Count, I need that many spaces on the first time through. Okay, but notice that I was, this down by 3 actually has to do with I. Okay, see, if this is how many spaces there are in row 1, there's 21 spaces in row 1. In this row, there's 21 minus 3 spaces. This is the way I should. This is 21 minus 3 spaces. Then here it's 21 minus 3 more. Then here it's 21 minus 3 minus 3 more. Okay, right? Keep on going. Okay, now what is that? This is the same thing as, this is row 1. Okay, this is row 1, row 2, row 3, row 4. In row 5, what am I going to do? 21 minus how many groups of 3? Okay, how many? Okay, I'm down here in row 5. How many groups of 3 am I subtracting off in row 5? 1, 2, 3, 1, 2, 3, 4, 5 groups of 3. Okay, okay, I'm grouping off 5 groups of 3. So that's I times 3. Okay, but if I want to make it that way, then I should start off with this one being 23 spaces. Let's see, 24 spaces 21 is the same thing as 24 minus I times 3. Okay, I is 1 here. So 21 spaces is 24 minus I minus 3. Okay, this one is equal to 24 minus I times 3. Okay, I is 2. 2 times 3 is 6. 24 minus 6 is 18. Okay, so here I'll simplify it a little bit. 24 minus I times 3. 24 minus, so this is 24 minus 1 times 3. This one is 24 minus 2 times 3. Okay, next one is 24 minus 3 times 3. Okay, because see, if I think about it, 24 is up to here. That's 24 spaces. Then I subtract off 3, or subtract off, or 24 is actually 1 past that. So that's 1 past that. Subtract off 3, subtract off 3 in the next one, subtract off 3 in the next one, subtract off 3 in the next one. So I want to start with the number of 24. That's actually one more, that's 1 space past the end of the 10. And then I'm in row 1, I should actually subtract off 3. Okay, so what do I have up here? It was J equals 24 minus 3 times I. Okay, it's a tricky one. Okay, takes a look, yeah, because I have to figure out how these spaces are decreasing. Okay, and it took me a little bit to see the pattern. Okay, because there's a couple ways of thinking about it. So it took a little bit while to see what was going on, that I should start with that number of spaces and say in row 1, I take off 3 from that number of spaces. In row 2, I take off 6 from that number of spaces. In row 3, I take off 9 from that number of spaces. Okay, so now then this will be starting at 1. I'm going to count up from 1 up to that many spaces. And then, oh, I wrote this one in the wrong place. And I'm just going to count up by ones now. Now I'm back to counting up by ones. Each iterate prints out 1 space. Each iterate prints out 1 space, and this is how many times I have to iterate. This is how many spaces there are. So this is my formula for, this is my formula for how many spaces are in each row. How many spaces are in each row? The formula is this 24 minus 3 times I. Okay, let's try it. See, so let's try this now. See, there's the output. Okay, and there's what we wanted. See, okay, lines up. Okay, now that's a bit of a tricky one. Okay, now this could be done a bunch of ways. So there'd be another way to do this one. Let's with the spaces variable. Remember, we started off by saying that you could do it with a spaces variable. Yeah. You could do it with the space. It'd be a good thing to try, because that's what this is all about, is just getting, saying, here's how I can solve a problem. Here's another way I can solve a problem. To be good at programming, you have to be able to see multiple ways of solving a problem, because because every way of solving the problem is giving you another little idea of how programming works. Okay, so in this case, we should be now we're going to turn it into a problem like one of these, where it says, given these strings, create this pattern. So what we can do is we can create this pattern partly. We can use a string for this pattern, a string of spaces for this pattern, Okay. So that would mean we don't need this loop here. And we go back to that idea that, oh, you just have a spaces variable here. Okay. There's some variable spaces, but then you're going to shrink it. Yeah. Then you have to take that string and shrink it a little bit. So it shrinks from there to there to there. Or another way to put it, it's actually probably a better way is to use a substring of it. Use some substring of that thing. So let's create a variable of that many spaces. So I'll copy that up to here. String spaces equal quote. That's how many spaces I need. So I just copied and pasted spaces from here up to here. Okay. So there's my maximum number of spaces. Okay. But then I have to keep taking substrings of it. Then down here, I have to figure out what would be so the substring is going to be, well, I need to trim that space off. I need to take this thing and trim it by 3s. So I need to take it and trim it by 3s. So next time I would need 3 less here. Then the next time I would need 3 less like that. But in fact, there's actually probably an easier trick to do it. Trim them off from the left end. Go, 3 less like that, then 3 less like that, okay? Because you trim off from the left end by calling substring with just a number there. Then that'll go from the beginning to the end, okay? So I want to do 3 steps of I. Let's try that, okay? If I'm in row I take off 3, See, I remember I take off 3 for every row I'm in. I take off 3 spaces for every row I'm in. So if I'm in a row, take off 3 spaces. Now in row 1, well, see, then I could start off by putting 3 more spaces in this thing. So I'm actually starting with something that's that long, like I did before, starting a little bit longer than it needs to be, so that when I have in row 1, I take off 3 spaces, okay? Then in row 2, I'll take off 6 spaces. So in row 1, I'll take off 3 spaces. In row 2, I'll take off 6 spaces. In row 3, I'll take off 9 spaces. Okay, so there's got all the spaces in it. Okay, let's see if this works. I think this is right now. Let's try this one. Oh, okay, kind of interesting pattern. Now look, something's right. We wanted 10, 11, 13, 16, 20, 25, 30, see that diagonal? It's there, 10, 11, 13, 16. What did I do wrong? See, it's kind of, what 10, see, that one did right, 10, then a bunch of spaces, 11. Oh, see, what did I do? Look, there's 11. Then it went 13, 14, 15. Okay, I did something dumb. What did I do? There's those spaces, but then I was supposed to go 16, 17, 18, 19. But then I did the spaces 16, spaces 17, spaces 18, spaces 19. I did something kind of dumb. Does anybody see what I did that's a little bit dumb? I got the right number of spaces there. I got the right number of spaces there. Then I went 11 spaces. Then there's the right number of spaces there. Then I went 13 spaces, 14 spaces. Then I went down here. There's the right number of spaces. Then 16, then the spaces, 17, then the spaces, 18, then the spaces. So now look at my code. What did I do kind of goofy? It's really kind of a dumb mistake.
Should the print statement be outside, or a separate print statement be in the outer for loop?
Yeah, these spaces weren't supposed to be part of this loop. I'm printing the spaces for every space. The spaces should have been up here. See, this these, I'm in the wrong, okay. This didn't belong there. I put it in the wrong place. This was supposed to be pulled out of here and made its own system dot out dot print. Up here, there's where that stuff went. And that'll be at the beginning of the line. Okay, so this will put the spaces at the beginning of the line, and then this loop will print the numbers across the rest of the line. So print the spaces at the beginning of the line, print the numbers across the line, end the line. Okay, so what I'm doing is I'm replacing this, what was this loop. See, this loop printed the spaces. Now that loop is being replaced by this one print line using that spaces variable. So I'm replacing a loop with a spaces variable and using the substring of that spaces variable. I use a substring of this thing. And actually, I don't need to, and the nice thing about using a substring is I don't have to chop this string off. I don't have to make this string shorter and shorter and shorter. I just take less and less substring of it. I take a shorter and shorter substring of that string. So that's a little bit easier than trying to make that string grow or shrink. Yeah, to make that string shrink, I just take a smaller substring of it. Okay, so now visualize this. There's the output. Okay, so there's another way. So this way, use 2 for loops, one loop to loop across that many spaces. So if you think like this row, one loop looped across that many spaces, and then the next loop looped across, then the next loop looped across that many numbers. So loop the spaces, loop the numbers. Okay, the other idea was, oh yeah, this is all just spaces, so why not just use substring of a big string of spaces? You know, that comes from the idea of these problems here. That's how they work. So why not be able to get the spaces down here as a substring of a long string of spaces? And that's what we did here. The spaces come from a substring of a long string of spaces. So we don't need a loop up for that one. We still can't get rid of this loop because this loop needs to change the numbers 13, 14, 15, 16. You know, there's not a constant string that this is a part of. This is not a part of some constant string, but yeah, the leading spaces are. That's one big long. So you just take 3 spaces less than it, 3 spaces less than it, 3 spaces less than it. So you can shrink that string and keep getting the leading spaces. Okay. All right, so there's 2 ways of doing that pattern. Okay, these are really good problems. Programming is nothing more than piecing together little problems like this until you get big problems that make you millions of dollars. But even a big problem that earns you millions of dollars is going to be made up of lots and lots and lots of little pieces like this. This is exactly what programmers do: is solve like there's actually kind of a rule of thumb in programming. Is see how I've written about 10 or 15 lines of code there? A lot of companies want everything you write to be in chunks of about 20 lines of code. So this is a method, and that method's 20 lines of code. And that's actually about the rule of thumb in a lot of companies. Anywhere from 20 up to maybe at most 50 lines of code should be one method. People don't write methods that are hundreds of lines of code. If they need hundreds of lines of code, there should be a dozen methods. And that's actually, so programming is about piecing together lots and lots and lots of medium-sized, small to medium-sized functions like this, okay? That do, the idea is do one thing only. There's even a name for that. This idea, do one thing only, the single responsibility principle, okay? It's part of, yeah, it's called the single responsibility principle, that you should only do one single thing, okay? It's even got a little Wikipedia page. You know, you should be writing shortish things that do one thing, okay? Every module, class, or function of your should have one responsibility over a single part of the program's functionality. You do just one little thing at a time. And you build up big programs by putting together hundreds or thousands, actually. A real, like, a web browser like this is actually going to be made up of just tens of thousands of small functions like this. So programmers actually spend a lot of time solving little problems like these. It's actually not it's a pretty common thing. Now the hard part is actually hard. The harder part is actually getting these things to all work together. You learn by writing. You start off by writing small things like this, and they're just like little one-off things. Draw this picture. So all these are little one-off things. Write the code that does that. Write the code that does that. And then later on, you'll learn how to design something longer, something that's 1,000 lines long, but you have to break it up into these small pieces. Then you think in terms of, how do I break the big thing up into small things? You should still be writing small things, but the hard part becomes, how do you break it up into small things and then write the small things? Okay. All right. Okay. What about another question from the review problems? Anybody have another question? Another one of these? These are good practice problems. These are the kinds of things that you need to be able to do. Anybody have another question? Anything else? Okay. On Wednesday or on Thursday, we're going to do it just like we did with the previous exam. We'll meet for class on Thursday, and the exam will be available on Brightspace right after class. So if you got questions on Thursday, we can, if there's some other problem you want to see done, we can also do another review problem or two on Thursday also. So the exam on Thursday will be like the previous exam. We'll meet for class on Thursday. We'll meet for class, and then just like it was before. Where was it? We meet for class, and then you'll go to the remember, this was the day of the exam. We'll meet for class, and then the exam will be available after class. So it's going to be just like that one. Okay. So it'll be just like the exam we had a month or so ago. Okay. So we'll meet for class, and then after class, the exam will be available, and then you'll have the whole rest of the day to do it. And if you have questions during the day, you can send me emails and ask questions. Okay. All right. So let's go ahead and start going back and do some more examples of arrays. Okay, so I've got some examples on a folder here. Okay, got a little folder of some examples. Can open them in Dr. Java, and then some of them will do in Dr. Java, and some will do in the Java visualizer. Okay. Okay, so first, arrays are objects. Actually, this is the one we should do in the Java visualizer, because I want to show pictures of the objects. So let me just go ahead and copy and paste this one up into the Java visualizer, because the Java visualizer is the best thing for visualizing what we mean when we say that arrays are objects. Okay, so I'm going to create an array variable. Now we're going to draw a picture on, we're going to draw a picture on the left. Actually, let me go ahead and start it. Okay. Here's where Java is going to draw the picture. This thing creates a variable. Notice that actually Java skipped right over it, because it doesn't give the variable a value yet. Then this creates the array object and makes the variable point at the array object. Now, there's nothing for this thing to point at yet, so the visualizer skipped over it. I mean, it should have kind of created a variable over here called myArray that didn't. Oh, actually, I can make it do that, but I have to cheat a little bit. Instead of leaving it empty, I can make it null. That's saying, make me a variable, but have it holding null so it doesn't point at anything. Okay, so see, now I'm at that line, and now I create the variable. See, I've got an array variable. Notice that, remember, that's not an array. That's an array variable. Just like whenever we work with objects before, the thing on the left is a name for the object. For example, like you'd have a name for a turtle, but it's not the turtle itself. Because we'll see in a minute, just like with turtles, you could have multiple names for the same object. This creates the object and makes this thing a name for it. There's the array object, and now this is a name for that object. Okay. Now I'm going to create two more. I'm going to create two more variables, but see how I skipped over there? I don't want to skip over them. So to create two more variables and not skip them, I make them null. Otherwise, the Java visualizer insists on skipping over them if I don't give them a null value. Okay. So my first variable, my first array. Now this line is going to create two more variables. See if I did, there's actually two things to do on line 12. So when I click forward one step, it creates one of the variables. And I click forward a second step, it does the second variable. So there was really two steps, and you can see it in the visualizer. The visualizer took two steps to do that line. So I'm at line 9. I create the array. So I finished line 9. I'm at line 12. I went from line 9 to 12. And now it takes two steps to do line 12. Notice that the last step was line 9. When I click forward, this thing will move to here because in the middle here, now the last step was 12. The last step was this half of 12. And the next step is this half of 12. Okay. So it's going to show this line in two steps. Okay. All right. So there's my two variables. Now I've got three names and one array. This one's a name for that array, and these two names don't have any arrays. They're not being used yet. Okay, so I have two array variables and one array. Okay, now what am I going to do with those two array variables? Well, I make one of them another name for my one array. So now that array has two names. Notice without a picture, it can be awfully hard to keep track of what this code is doing. The pictures are real important. Okay, so like the next line, it actually creates a second array. So now I have three variables, but two array objects. Okay, and you have to keep straight, all this code. It's real easy to write this code in a way that can be very hard to follow because you can make these names jump around between the two array objects. So we have three names and two arrays, and I can make the names bounce around between the two arrays. And you need a picture to keep straight which array is naming which variable is naming which array. So those two variables name that array, and this one names right now this other array. Okay. Now here's a loop that's going to put something in this array. Okay. So I'm looping on that array. So I'm putting something in that array. Actually, no, I'm not putting anything in it. I'm printing it out. So there's a loop printing out what's in this array. So I'm going to create a variable I for the loop. Okay. And I'm going to start stepping. And I'm going to print it out over here, down here. So I'm just printing out the zeros. Okay. So I'm printing out the zeros in that array. Okay. And there's 10 of them. Okay. So I finished printing out that array. So I printed out that array. Now I'm going to put something in. Now I'm going to use this variable to put something in that array. Okay. So now I'm looping on this array and putting something into it. Okay. So now you can see the numbers are being put into that array. I'm putting the squares of the integers in there. Okay. So it's going to be 1, 4, 9, 16, 25, 36. Okay. So I'm putting in the, okay, that should be the last one. Okay. Now I'm done. So I filled that array with the squares of the integers. And now I'm going to print out that array. But that array is that one. See, my array is that one. So I'm printing out the one I just filled in because the array's got two names. So it looks like I'm filling in one array and printing out a different array, but that's not, if you don't read the code carefully, you would say, oh, this fills in one array and this one prints out some other array. But it's not the case that this one prints out some other array because those are names of the same array. So now this one's going to print out see, it's printing out the squares. Okay. So the thing is that arrays are objects, just like turtles and strings and things like that were objects, and you have to be careful to distinguish the name of the array from the array itself. Because you can't just look at the code and think that, oh, that's got a name and that's got a name, so they're different arrays. You have to look carefully at the code and say, which array object is that? Which array object is that? And that's where the pictures come in. So the pictures will help you keep track of the fact that these are, in this case, this and this are the same array object. Okay, so that's something we have to keep in mind all the time, that arrays are objects. So we have to separate the reference variable from the array itself. Okay, so that's a pretty simple example. There's not a whole lot to it. It's just a reminder that we have to be careful of the arrays, just like we were careful with things like strings and turtles. That you have to know which object your variables are pointing at. Okay, all right. Now let's look at another example. Let me just okay. When you work with arrays, you have to be careful not to. There's this idea that an array has a size, and you have to stay within the size of the array. Okay, so I think we can do this one. Let me copy it up to the visualizer. Should be able to see this. This one's simple enough to also see work with inside the visualizer. Okay, one thing that's new is I'm gonna fill the array with random numbers. So the textbooks mention this idea that you can create random numbers. We haven't used it a whole lot, but with arrays, it's a real convenient thing to do. It's, in the last example, I put numbers in the array by like counting up, for example. So I counted up and squared a bunch of numbers. Okay, but there's just so many ways you can fill an array by looping on the array. So sometimes it's just nice to fill an array with, say, random numbers. So you could do interesting things with, you can search for a number, sort the array. So it's real common to want to fill arrays with random numbers, especially for homework problems. So so this example is going to fill an array with random numbers, but then it's going to show you that what you can do wrong with an array. This idea of an index out of bounds. Okay, so I'm going to create an array of size 10. Well, let me just go over to the visualize part. Create an array of size 10. Okay, it's just got zeros in it. When you create an array and you don't put anything in it, it's filled with zeros. If it's an array of ints, it's filled with zeros. If it's an array of doubles, it would be filled with 0.0. Okay. Then I create a random number generator, something that an object. See, it's an object. It's an object that knows how to generate a sequence of random numbers. Essentially, it knows how to roll a dice. Okay. So it's an object that's written for us in the Java language that just every time you call it, it'll give you back a randomly chosen number. Okay. Okay. Now, what I want to do is I want to fill the array up with random numbers. Now, here's how you ask for a random number. You take that object. See, there's the name of the object, and you call the next int. It should have been next random int, but that's kind of redundant because you usually give the thing the name random. Okay. It's an object of type random. We usually call an object of that type random, and then you ask for the next int. But it probably would have been better for them to call that next random int, because it looks too much like the method you use, for example, from scanner when you ask for next int. But when you ask a scanner for the next int, it gets it from the keyboard. When you ask a random object for the next int, it rolls a dice essentially and generates one for you. And it generates a random number between 0 and this number minus 1. So this will generate a random number between 0 and 9. It's kind of a weird thing. Why don't they just make it between 1 and 10? They don't. If you give it the number 10, it generates a random number between 0 and 9. That's 10 choices, but starting with 0. So then I add 1 to it, and I get a random number between 1 and 10. So there are dice sometimes that have a 0 face. Most dice are one, like most die are 1, 2, 3, 4, 5, 6, not 0, 1, 2, 3, 4, 5. But in Java and same in C and C++ and Python and all these other languages, when you ask for a random number, you say, I want a random number chosen between 0 and this minus 1. Okay, so that means there's 10 choices. This is how many choices there are, but the numbers are 0 up to 9. Okay, so if you add 1 to it, you get a random number between 1 and 10, and then put that in the array. Okay, so start looping. Okay, so 7 in the first slot, 8 in the second, 1 in the second slot, 7, 4. See, I'm getting random sequence of numbers. Okay, now how many do I need? The array has length 10. Okay, so I want to go up to the length of the array. Okay, so I would say, and notice that the array indices start at 0, so I have to start my I at 0. Okay, it's real important to remember, array indices start at 0, so all my array loops should start with the index I being at 0. Okay, then I want to go up to the end of the array. But notice that the array of length 10, now this is kind of why the random number generator gives you numbers between 0 and 9. Notice in programming, you always start counting from 0. So see how that counts up from 0 to 9. It's an array of 10 objects indexed from 0 to 9. Now that means that I have a bug. We're going to see in a minute. There's a bug right there. There is no entry at 10. 10 is the length. There is no entry there. So when I step through this array, eventually I'm going to hit a problem. Okay, so there I is 9. I'm filling in the last number. The last number I'm filling in with the random number 8. Now I is going to go up to 10. So I'm right here. I'm incrementing I. I is 10. Now I go back here. I is less than or equal to 10, right? See, this is the length of the array, which is 10. So I is less than or equal to 10, so that's okay. So now I go down here, and now I'm going to put something in slot 10. But there is no slot 10. And my program's going to blow up. See, my program crashed at that point. See, it stopped iterating. See, my program stopped. I can't go forward. You know, my program halted with an error. There is no 10th index. This loop was not supposed to be less than or equal to the length of the array. This is a real easy mistake to make when you're writing programs with loops. You think, well, I have to start at 0 because every array starts with an index 0, and I have to go up to the length of the array. But there is no slot that has the length of the array as index. So what you're supposed to do is go up to strictly less than the length of the array. Okay, so you should write it that way. Start with I equals, this is a pattern we keep using over and over again with arrays. If we want to step from one end of the array to the other, from beginning to end, we loop from I equals 0, I strictly less than the array dot length, strictly less than the length of the array, and step through the array one step at a time. Okay, so now it'll get to the end. Okay, now I'm filling in, now I'm going to fill in the 9th slot. Okay, I is 9. I'm filling in the 9th slot. I put an 8 in the 9th slot. Okay, now I go back up here. I increment I to 10. So I just incremented I to 10. And now 10 is not strictly less than the length of the array. 10 is the length of the array. So now this is going to become false. And I won't try to put something off the end of the array here. I won't try to put something over off the end. So the loop will end like it should. Now, so here's just shows you directly. You can't, there is no 10th element of the array. So that line, that's the line that makes the program crash. There is no 10th item in the array. Okay. Now, similarly, there's no 15th item in the array either. That would crash the array too. And it also, there's no negative indices. So now what's interesting is the compiler doesn't even pay attention to that. The compiler could warn me that this makes no sense. Arrays never have a negative index. Notice the compiler didn't care. The compiler will never check your code for what's in your array indices. Even when it can see that they make no sense, it's going to let you go up to there and blow up. Okay? There is no negative index in an array. Okay? So when I tried to run the program, I just hit the last button so it would go all the way up to the end. So it filled in the array with the random numbers. Then it got to line 26 and it blew up. There is no negative index. Okay. All right. So the indices are from 0 up to, now here's something that you can do. The name of the array is random ints. Okay. The last entry in the array is randomints.length -1. There's the last entry in the array. If I wanted to, I could write that. That would put 5 in the last entry of the array. And we can go here and we'll see that put a 5 there. Now, what's the advantage of writing a line of code like this? If I change the length of the array up here, suppose I change the length of the array to 17. This line of code still puts something in the last entry in the array. Because whatever I make the array, whatever I decide the array length should be, this is the way I put something at the end of the array. The name of the array dot length -1 is the last entry in the array. So that's still going to put something, doesn't matter how big the array is, that's going to put something, that's going to put 5 at the end of the array. So here now I put it in entry 16. Okay, because the array had length 17, so 17 -1 was 16. Yeah, so that's a real useful little piece of code like that, because I can make the array any length I want, and this will always this will be the last entry in the array. Now the array only has 6 items in it, but I put 5 in the last slot. Okay, so this is a convenient thing to remember, that this is the way you put something at the end of an array. You do the name of the array dot length -1. Now that's better than if I go over here and say, oh, my length has array 10, so the last thing in the array is slot 9. That's not really a good idea, because then if you change this, you have to remember to change that, which is not, that's not likely to happen. If you're writing a large program and you decide to change the size of that array, you may forget to change places like this. So it's better to call, instead of saying, oh, the array is length 10, so the last slot is 9, you're better off saying that the last slot is always that. Use that to represent the last element in the array. Okay. All right. So be careful. Arrays have a fixed length, and you can't go over the left end or past the right end. Whenever you have an array, you can't, there's nothing to the left of 0, there's nothing to the right of length of the array -1. The last entry is always going to be the length of the array -1. And the most important one to remember is that there's no entry at, you gotta be careful about that one, random ints.length. This one, that looks like a reasonable thing. A lot of times, especially beginning, people think, oh, that's the last entry in the array, but that's guaranteed to always be wrong. Yeah, no array ever has an element at its length. There is no element at index length. There is no element at index length. So this has length 10, and there is no element 10. Okay, so that's the wrong way to put something at the end of array. And remember that, oops. This is the right way to put something at the end of an array. Okay, the right way and the wrong way to put something at the end of an array. Okay, all right. Now let's look at another example. Okay. Okay. I'm trying to think which one we should do next. There's a bunch of just like we drew lots of pictures. We used, we did the example at the beginning of today of drawing a picture, using code to draw a picture like this. There's yeah, and we just do example after example like this because these are common patterns of programming. These pictures are actually surprisingly, useful ideas for programming. There's similar problems for arrays. There's lots of patterns of problems, lots of problems that you see over and over again in book after book, or you see, people use all the time, what we call like searching for an array, counting the, so here's a few examples. Count occurrences fills an array with random numbers, and then picks a number and says, how many times is it in an array? It counts how many times the number appears in an array. Largest and smallest will go through an array and find the biggest number in the array and the smallest number in the array. And search array is similar to count occurrences. Count occurrence says, how many times does the number 5 appear in the array? Search just says, does the number 5 appear in the array? And wants an answer yes or no. So these are common things you do with arrays. Ask if a certain number is in the array. Or a little bit more information, say, well, how many times is the number in the array? And then things like, what's the largest number in the array? What's the smallest number in the array? They're very similar things to do. So these are very similar examples. Let's start with, let's see which one I have here. Let's start with count occurrences. Okay, we want to count the number of times a particular number is in an array. Okay, and what we'll do is we'll fill the array with random numbers, and then we'll just pick a number and ask how many times, that number in the array. So, and actually, I did something odd here. I don't know if this will work. I tried to. This is this is an array of 1 billion items. That's a pretty big array. Okay, so I'm going to create an array that holds 1 billion numbers. I'm going to fill it with random number. I'm going to create a random number generator. Then this will fill the array with random numbers between 1 and 100. Okay, so I'm going to fill the array with random numbers between 1 and 100. Okay, and then I'm going to ask how many times did the number 100 appear in there. So the number I'm going to search for is the number 100. Okay, then this will be this creates the array, creates the random number generator, fills the array. So this gives us our data to work with, picks the number, and then the actual loop that does count occurrences is right here. So there's the loop that will count how many times a number's in the array. And it's real simple. I create a counter that'll do the counting for me. I'm going to start the beginning of the array and go all the way up to the end of it. So there's the way I go up to the end of it. I strictly less than the length of the array. So that's using the idea from the last example. That takes me up to the last item in the array. And then I just ask, is the ith element in the array the number I'm looking for? If it is, count it. Notice I don't need an else here, because if the number I'm looking at is not the number I'm looking for, there's nothing to do. So that's a good example of an if that just doesn't need an else to it. Okay, so if I found the number I'm looking for, I count it. And then at the end, I can print out the number. Okay, so I can compile this, run it. Notice it's running. It needs to do a lot of work. I'm asking it to count 1 billion numbers. Okay, notice it didn't take that long. One of the things to realize is modern computers are tremendously fast. Asking it to do 1 billion things is not really that big of a deal. Asking it to, if I had run this on a computer 10 years ago, I would have sat here for a while and waited. Computers would just keep getting faster and faster. So it's, 1 billion is not a big deal anymore. And we found the number that many times. Remember in the homework assignment, I asked you to print numbers with commas in them. So I actually should have used that here. I should have printed that number in the way that put commas in it, because it's kind of hard to read. So that is the number. There's 10 million. Okay, so I found it on the order of 10 million. Is that right? Yeah, 10 million 100s. Okay, now I could run it again. Notice, I'll get a different every time I run it. I get a different number. Found a little bit less. Here's something that's a little bit interesting. If there's a program on your computer called Task Manager that lets you ask questions about how your computer is running, and over here I can look at graphs of memory usage. Okay, see this dip? What happened was when I ran my program, it used up a lot more memory. And then when I ran it again, it had to reclaim some memory. So that dip is when I ran the program a second time. Like now, let me go over here and run it a third time. See that big dip in memory? Dr. Java had to ask the operating system back for the memory it had given it. So it reclaimed a bunch of memory. This will be about a couple. This is going to be like a gigabyte of memory here, and then it reclaimed it and started using it again. So what it did is essentially it deleted the old version of the array and created a new one. You'd think it would delete the array when the program is done, but it doesn't delete the array until the next time you run the program. So see if I run it again, I'll see a big drop in memory. That's when it actually deletes the array that it created for the last time it ran. So run it again. It deleted the array from the last time, and then it had to reclaim enough memory to build another array. Okay, so my program, I can actually see my computer. Now notice my computer has 16 gigabytes of memory, and this was about 2 gigabytes of memory to create the array. Okay, the array holds 1 billion integers, and it needs a couple gigabytes of memory to hold that array. So if I made that number much bigger, I would start having issue with not enough memory. Like if I made that 16 gigabytes, I have only that much memory on my computer. I don't even know if that would run. Like I don't know if this one will run if I ask it for 16 gigabytes. So recompile it. Oh, that's too large a number. No, so I can't ask for that much memory. Yeah. Let's see. I'm not sure what's the biggest amount I can even ask for. I don't know if it'll. That's too big. 9 gigabytes. That's too big. 5 gigabytes. Still too big. Okay, there's asking for 2 gigabytes. That's asking for 2 billion items in my array. That's twice as big as it was before. I'm not sure. I can't go to 3. The compiler won't let me go to 3. So I'm pushing the limits of what the computer can do and what Java can do here. So there's asking for 2. If I run it, oh, and then it blew up. It could not do 2 gigabytes. See, I ran out of heap space. There wasn't enough memory. Java didn't have. My computer actually has enough memory, but Java doesn't know how to use that much memory. Okay, I'd have to do something else. I'd have to get Dr. Java. I'd have to run. Dr. Java doesn't know how to make an array that big. My computer could actually do it, but Dr. Java wouldn't be able to. Okay, so you can actually. This is the kind of stuff you'll start learning more about. Is actually watching your programs run. For example, with Task Manager, seeing how much CPU time it would use. Like if I go back here to the 1 gigabyte case, and I run this, you'll see that it actually keeps my computer kind of busy. The CPU now it's at 46% utilization. That's more then now it drops down to 24. See, the 22% utilization is my CPU doing Zoom. My computer, that's about the workload of doing Zoom. Okay, so the CPU is about that busy trying to keep up with Zoom. And then if I run this program, it becomes about twice as busy. See, now it's running, and now it's creating that array, filling it with random numbers, searching the array, and see, you can see the CPU is busy. Then when I get the answer down here, the CPU will become much less busy. There, see, it became much less busy when the answer was done. So I can see the computer working on this program. this program is big enough that I can actually see the CPU doing it, and I can see the memory being used for it. And that's one of the things you learn more about as in the more advanced computer science classes. We pay attention to how our programs actually run on the computer. When we now arrays are where you can start playing around with this. Once you have arrays, you can ask for massive sized arrays. You can ask for 1 billion items in your array. So arrays let you do things where you can have massive amounts of data and actually have your computer do some work. Okay, so there was a simple loop that counted entries in an array. And then what we'll do on Thursday is we'll look at these other examples of finding the largest and smallest number in an array, and also asking, we counted how many times a number is in an array. I could just say, well, let me know if the number is in the array or not. Okay, not every number it has to be in the array. So I could ask, well, is this number in the array or not? Okay, so that would be searching an array. We'll see, and we'll do that one a bunch of different ways. We'll see that one's kind of interesting. We'll do it 4 different ways. We'll search the array 4 different ways. So this is a lot like the stuff with drawing pictures. We just keep doing example after example of drawing pictures, and they're very similar examples, but they give you practice in thinking. We do lots of similar array problems, and they're practice in thinking. Search an array, count how many times something is in an array. We'll do something. We'll try to sort the numbers in an array. We'll do various things with the numbers in arrays, and it's just practice. Practice with thinking about arrays and practice with writing code. Okay, so run out of time. We'll quit there. And then, so on Thursday's the day of the exam. We'll meet on Thursday. Remember, we'll meet on Thursday, just like we did the last exam. If you have questions about the review problems, you can have some questions. You can ask questions about the review problems. Otherwise, we'll go back and do some more of these examples of the arrays. And then the exam will be after class, and you have the whole rest of the day to do it. It'll be due like 11 o'clock at night. Okay. And if you have questions, you can send me email. And during the exam, if you have questions, you can send me email. I'll have classes during the day, but I'll try to answer the email as they come in. And so that'll be Thursday. If you have questions before the exam, you can send me email or come to office hours today. Okay. All right. So we'll quit there, and we'll meet again on Thursday. Any last question? Anybody got a last second question? Okay, so meet again on Thursday. Bye.